Hello everyone. I want to explain the safety analysis environment by adding PSV or PRD. First of all, in the simulation environment, as you see, input changed, so I should run the flow diagram and get the results that are available for this flow sheet. The control panel says that the process of run is complete with no errors and only one warning that is not important. So after getting the results, I can go to the safety analysis environment. I click on this part and enter the safety analysis environment to add the PSV and rupture disk and the other things that is needed to analyze. When I enter the safety analysis environment, a red blue rectangle around the diagram flow sheet has appeared, and it means that everything is locked. I cannot change any parameters of the vessels. So I click on the add PSV, and when I enter the flow sheet, as you see, a sign plus appears, and I want to add on the S6 stream the 1 PSV outlet of the valve 2. When I close the S6 stream, a small blue square appears. I click on this part 2 times, and PSV is added here, PSV 1 to protect valve 2. So as you see, when I add PSV 1 on S6 stream and the navigation pane under the valve 2, PSV 1 is added. I can click on this part or click on the PSV 1 in the flow sheet. I click on this part and goes to the another window that shows these tabs about the PSV. As you see, equipment, scenarios, PRD data, rating and line sizing for PSV 1. The unit operation that is protected is valve 2, and operating temperature, design temperature, operating pressure and design pressure. For all of these 4 parameters, you can see the reference and manual in the list. I can choose reference. When I choose reference, it shows the temperature, operating temperature of the equipment that is protected, and when I choose manual, I can change the parameter or change the value as I want to add for the S6 string. The design temperature can be chosen here, 80 degrees centigrade. Also operating pressure and design pressure as the reference can be according to the reference. I can change this to, for example, 6 bar gauge, the design pressure. It says to me that I should create an emergency scenario. A yellow ribbon appears here, and I should go to the scenarios field. I click on this part and create scenario for the PSV 1 as protected valve 2 according to this part. Scenario 1 is added. I can type on this list. For example, for the valve 2, I can choose the abnormal flow through the valve and change the name to AB, and I can choose the sizing case. It says to me a reference stream must be selected to calculate the relief properties. As I click on the AB scenario and I click on this part, as you see, a bright blue ribbon appears here, and 3 fields are active, open scenario, duplicate and rename, and delete scenario. I can then duplicate this scenario, for example, as you see, and I can choose this one and delete this scenario by this field or tab. But I choose the abnormal flow through the valve as a scenario and open this scenario and go to the other window that shows the properties of the scenario that are added to this window. The scenario name, AB, scenario type, abnormal flow through the valve, and this frame that shows the scenario reference stream. I should select the reference stream that is protected by the PSP valve 1 SC. Relieving temperature. From the drop down list you can select the reference, but I use the manual part and 70 degrees centigrade for the relieving temperature. And the relieving pressure, I choose the edit part and click on this part. As you see, the set pressure equals to design pressure 60 bar gauge. Allowable overpressure is 10% of set pressure. For this scenario, the allowable overpressure is 10%. If we choose the fire scenario, the allowable overpressure changes to 21% of set pressure, and if we choose the multiple valves, the allowable overpressure changes to 60% of set pressure. And the relieving pressure is the sum of the set pressure plus allowable overpressure, 60.6 bar gauge. Total back pressure, I click on this part, edit part. As you see, the atmospheric pressure is 1 bar absolute. We can change this from the preferences manager. As you see from this part, the general setup field, barometric pressure can be changed, for example 1.2 bar absolute, and click on done. And if I click on the edit part, you can see the atmospheric pressure is changing here. The constant superimposed back pressure is the pressure that on the outlet or tailpipe of the valve that imposed by the discharge environment. It is not varying based on the state of the discharge pressure, and the default for constant superimposed back pressure is atmospheric pressure, as you see. The variable superimposed back pressure is the back pressure on the tailpipe imposed by the discharged environment, and based on the state of the discharge environment, and the default value is 0. I can change this part, but for example 0.2 bar gauge. Build-up back pressure is the pressure drop in the tailpipe, so I don't change this part. The total back pressure is the sum of the constant superimposed back pressure, variable superimposed back pressure, and build-up back pressure. As you see, it is 1.6. It is the constant superimposed back pressure is 0 at bar gauge, and so the variable superimposed back pressure plus build-up back pressure is sum of these three values. It is the pressure that's used to calculate the properties of the fluid in the tailpipe of the discharge environment, and this pressure is some of the superimposed back pressure and build-up back pressure and constant and variable superimposed back pressure and build-up back pressure. Maximum allowable back pressure, as you see from the the previous part, was 10% of set pressure, and maximum allowable back pressure is 1.6. It is the percentage of the set pressure allowed as back pressure on the valve, and it depends on the continuation of the simulation. Back pressure factor. Maximum allowable back pressure, it is the percentage of the set pressure allowed as back pressure on the valve, and the maximum allowable back pressure is depends on the set pressure and type of the valve. And the back pressure factor KB, as I choose to calculate it, as you see for this type of the valve, the conventional valve, this value is equaling to 1, and if I choose the specified one, the back pressure factor can be changed here according to the type of the valve. Okay, I choose on this part. Relieving phase. As you see, the relieving phase is liquid, and I can choose from the drop down list the capacity certified liquid as the method to calculate the relieving flow through the valve, or non-capacity certified liquid, or direct integration HEM. So the default is direct integration HEM, so I don't alter this definition in this default. The viscosity correction KV, when we use when we have the liquid that the viscosity of this liquid is far from the water, we can change this, and it depends on the Reynolds number, so I don't change this value. The required relieving flow, as you see, we can choose the reference part. If I change if I choose the reference, the required relieving flow is 4.8 to the power of 4 kilogram per hour, but I choose the manual and change this value 50,000 kilogram per hour. And this frame shows the PSV results. As you see, the calculated orifice centimeter to the power of 2 is 9.1, and I choose the selected orifice from this drop down list, 11.8 K type for the selected orifice. The other values are described here: fraction of full lift and rated capacity, and the other ones. The discharge coefficient for this device, the discharge coefficient for two-phase flow or liquid service is 0.65. If I want to change this value, I can click on this part bar. Liquid is the default of the phase, relieving phase, so 0.65 is the software default, and I don't change this value. Okay, I'll be back to PSV1 and go to the PRE data. PSV1 orifice area calculated and selected are empty. As you see, the warning, the yellow ribbon warning is appear here. It says please select a sizing case, so I should be back to the scenario and select this scenario as the sizing case, and go to the scenario part and select this sizing case. The orifice calculation is completed, so I'll be back to PSV1 and go to the PRE data field. As you see from the window, we can have the PRE name as PSV1, orifice area centimeter to the power of 2 for calculated and selected. Orifice area, the flange size and rating 3 inches for inlet pipe and 4 inches for outlet pipe, and also 150 for rating the flange size, and also the statute of warning says the orifice calculation is completed because the green ribbon is here, says okay for the simulation. The other frame says the general parameters for the simulation. PRE type, it is relief valve, as we have the liquid as the flowing flow through the PSV. PRE name, I can change this from this part, and PRE service also I can change it to liquid, for example, liquid liquid. Code design, as you see, we have 4 code design: ASME section 8, PD 5000-5000, and ASME section 1. I don't change the design code for my simulation. Discharge to low pressure flare, the default is flare, but I changed to low pressure flare. Constant superimposed back pressure is 1 atmosphere, and the other frames shows the PRD specifics. PRD suffix is not so important. It's a unique identifier for valve or rupture disc where we have multiple valves for our simulation. Set pressure can be set design pressure. If I choose the design pressure, the set pressure equals to design pressure 6 bar gauge, but if I deselect the design pressure, I can change this part. I don't change the set pressure. The other window says the pressure relief device selection. The type of the set PSP can be chosen here, balanced and below, or pilot operated according to our usage in the flow diagram. And also the body material, the stainless steel, can be chosen, chrome molybdenum, everything you want. It says the chrome molybdenum. If I choose the chrome molybdenum, it says no IPI valve was found for a selected orifice and material, so I should change it to carbon steel, for example. RD combination KC, it says that if I choose the rupture disc downstream of the PSV valve, I should select this part, and the RD combination can be changed to 0.9. But I don't choose the rupture disc downstream of the PSV. And also, if I choose the restricted lift valve and choose this part, it says to me that the fraction of the lift of the fraction lift of the PSV valve to the full lift can be 0.9, and it decreases the flow that is flowing through the PSV valve, because I have the liquid in the phase of the PSV flowing flow through the PSV valve. I choose 0.9. And the other frame says the sizing scenario parameters, the scenario name AB, abnormal flow through the valve scenario type, relieving temperature, relieving pressure, total back pressure, the state of the relieving phase, and discharge coefficient. So I'll go to the rating part, rating field. The scenario name is here, scenario type, phase, required flow, total orifice required, and total selected orifice. From this window, you can see the PRE configurations. The set pressure increase as percentage is 0, and the set pressure as bar gauge is 6 bar gauge, and a lower over pressure according to these special scenario is 10% of the set pressure. Relieving pressure 6.6. It's the summation of allowable overpressure and set pressure. Required flow split in what percentage is 100, and flow amount as unit kilogram per hour is the required flow, 5 to the power of 4 kilogram per hour. Calculated orifice, selected orifice, fraction of full lift, as you see in the PRD data part. The restricted lift valve is the fraction of lift to full lift valve is abbreviated here, and 0.9. Rated flow, it is the maximum flow that can be flown through the PSV, 5.8 to the power of 4 kilogram per hour. And also the capacity percentage for the rated flow is 160%. The display rating streams can be chosen from this part. When I change this value to the flow amount used, for example kilogram per hour, it shows the flow that is flowing through the PSV valve as required relieving flow. When I choose the percentage orifice area, you can see the 86% of the orifice area can be used to flow the required flow through the valve. and also orifice used. You can see the calculated orifice that is used in the PSV, and if I use the split of total required flow, you can see that 100% can be seen here. In this window you can see the emergency scenario name, the type of the scenario name, and required flow, and also the abbreviation of the calculated orifice, 9.80 centimeter to the power of 2, and PRD sizing method as direct integration HEM. I'll go to the line sizing PSV1. You see two tabs, design tab and rating tab. First, I explain about the design tab. The state of phase or method is direct integration HEM. Flow rate method can be changed from the drop-down list. If I change the rated area, you can see the flow rate as kilogram per hour is here, changes 5.8 to the power of 4 kilogram per hour. And if I change to the required, it changes to 5 to the power of 4 kilogram per hour. And if I change to the manual, I can choose everything that I want to consider as a relieving flow rate which passes through the pipes. But I choose the required as the relieving flow. And it said the yellow ribbon says to me that run line sizing. For this scenario, current scenario is AB, abnormal flow through the valve. I run line sizing in design tab. It takes some seconds to run. Okay, inlet line pressure, that was okay. First of all, I should change this value to 4 inches, and I should explain about the material material of the pipe. It can be selected from this part, user specified, and smooth or user specified mild steel. If I choose the smooth as the material of the PSV, the roughness as millimeter is 0, and if I choose mild steel, the roughness can be changed to 4.5 to the power of -2 as the roughness. And also I can change the specified equivalent length meter or 105 meter as the value for the pipe length. For the inlet and outlet pipes, I should calculate on the paper the fittings wedges, all the fittings, all the T's, all the valves, gate valves, and all the other things, and choose the equivalent length, and enter the value of the equivalent length here as the inline and outline for the pipe. The elevation for the inlet pipe can be chosen here, and the elevation of the outlet pipe can be chosen. Both of them are 0 for my piping. And if I run line sizing, it takes some seconds. And as you see, it says to me that inline line pressure drop is okay, but outline line pressure drop has error. Back pressure exceeds the maximum allowed by PSV. And the other errors, outline line pressure drop check, it says that calculated pressure drop 0.9 is higher than the specified build-up back pressure 0.6. Modify your specification. And for outlet line velocity exit, it says that fluid velocity as pipe exit is higher than the 90% of critical velocity. So for this modification, I'll go back to the scenario tab, click on this part, open the scenario, and total back pressure. As you see, the build-up back pressure should be modified. 1.1 bar gauge, variable superimposed back pressure. It's okay, for example 1 point, and then it says they exceeded 10% limit on build-up back pressure. Build-up back pressure is so high, so I'll be back here. Build-up back pressure, I can change this to 80%, as I'll be back to the PSV1 and line sizing 0.3 or 1.3 meter for the specified equivalent length, but it's okay. I should not change this part. I should change this part as the tailpipe and run line sizing. It takes some seconds. Okay. Again, it said that the athlon line pressure, calculated pressure drop is higher than the specified one. So I'll be back to the scenarios part, select this part, and total back pressure 0.97. Okay, I'll be back to the PSV1 and line sizing PSV1, and again I run line sizing. It takes some seconds. Okay, the one of the errors is removed, and it says the fluid velocity at pipe exit is higher than 90%, so I should choose a pipe that is the diameter of the pipe is higher than the PSV flange size. So I should run line sizing. Again, as you see, for this scenario, the fluid velocity as pipe exit is higher than okay, I'll change the outlet line to 6 inches, run line sizing again. It says inlet line pressure drop is okay, and my simulation is completed for this current scenario. If I want to choose another scenario, I'll go to the scenarios field and create scenario again, and I choose the blocked outlet for this scenario as a type of the scenario, and change the name of the scenario and choose the sizing case for blocked value. It says that it should be blocked valve. It said the reference stream must be selected in order to calculate that relief properties. So I'll go to the open the scenario for blocked valve, blocked outlet valve, and open the scenario for this. As you see, the scenario name is blocked outlet, BL, blocked outlet, the type of the scenario, and select the stream S6, and I choose 70 manual, 70 degrees centigrade for relieving temperature, and also I choose the 0.97 and 0.1 as the variable superimposed back pressure, and build up back pressure, the pressure drop in the tailpipe, and the other things. The required relieving flow is 50,000 to the power of 4 kilogram per hour, and I choose car type for the selected orifice. Again, it says the exceeded 10% limit and build up back pressure. Okay, it's so important. So I'll be back to the PSV1 for this special scenario, the PRD data. The restricted lift valve is checked, and okay, rating part, rating field You see the low level overpressure 10% for this scenario, and also you can see two scenarios in this window. The emergency scenario named abnormal flow, it was the first scenario, and blocked outlet was the second scenario for this valve. I'll go to the line sizing PSV. As you see, we don't change anything, and rated area is as the flow rate method. I run for all scenarios and wait to run all these simulation for all the scenarios: blocked outlet and abnormal flow through the valve. It takes some seconds, and I should be patient for this. Okay, it says that the back pressure exceeds the maximum allowable by PSV because the maximum allowable or pressure drop for PSV at the outlet line is 0.6 and the calculated is 0.8. So I'll be back to the scenarios part and go to this special scenario, open the scenario and change this part to, for example, 1 bar gauge. Okay, I'll be back to the PSV1 and line sizing PSV1, run for all scenarios, and it takes some seconds. Again, it says the back pressure exceeds the maximum allowable by PSV. The maximum that is allowed by PSV is 0.6 and the calculated is 0.8. So I should choose something that the pressure drop in the back and the outlet line decreases, and I should choose the, for example, 0.9 meter as a specified equivalent length, and run for all the scenarios part. Again, it says the outlet line pressure drop exceeds the maximum allowable by PSV, so I choose the required flow as the method and run for all sizing because the required flow is lower than the rated flow, and the pressure drop depends on the flow of the outlet line. So if I run for all scenarios, I can see if the pressure drop, maximum allowable pressure drop for the tail pump is appropriate for this simulation or not, and I should wait and hold. Okay, the inlet line pressure drop. Okay, the simulation is complete. So if I want to explain about the rating tab, I can choose this part and edit pipes and fittings. I should first of all remove this part because first okay, as you see, when I click on edit pipes and fittings, you can see the PSV as the pressure relief valve, the PSV inlet flange and the PSV outlet flange. If I choose the PSV inlet flange and choose and add above, I can choose the pipe or fitting here. For example, I can choose pipe or fitting, and then type of the fitting here I can choose, for example, a gate valve, a bend 90 degrees, and the schedule of the bend, nominal diameter, in inline, and inlet line thickness can be specified here by choosing the mild steel as the material of the bend, and the roughness can be chosen here based on the mild steel material. And also the other thing, the quantity of the bend can be chosen here, and the source, that is and the source of the fitting that adapted to this part is shown here, crane 450M. Then I have a pipe, PSP inlet flange, then pipe. It is a pipe, so I choose this part and add above a pipe, and schedule of the pipe, 3-inch nominal diameter, internal diameter, thickness of the this part can be shown here, material of the pipe can be chosen here, and the length of the pipe, for example 1 meter, and the elevation of the pipe can be shown here. And also at the outlet of the pipe I choose this row and add below. After the flange, outlet flange, we can have a pipe, and according to the piping system, and 4 nominal diameter for the pipe, 4 inches. The other specifications, smooth, for example, length of the pipe 1 meter, and also I accept this and go to the run for all scenarios part for the rating tab, and flow rate method as required. I should wait some seconds or some minutes to run the simulation in the safety analysis environment, so I should be patient and run line sizing for calculating pressure loss, pressure drops in the outlets and inlet pipes according to the rating part. So it says that how the little line sizing calculation failed. Check flow rates and line sizes. I should be back to edit pipes and fittings, and I choose this part and add below the for example a fitting. The fitting can be elbow, no, can be a T. For example, I choose a T. Branch to run or run to branch is it's appropriate for its piping, and the 4-inch to 4-inch, but it is 5-inch. It is specified mild steel, and also after the T you can add a pipe that is 6 inches. After the T, the material should be mild steel and 0.5, and also you can add another pipe after the T, pipe 6 inches, mild steel 0.5, and accept. Okay, I run for all scenarios. Okay, it says that the back pressure drop exceeds the maximum allowable by pressure drop. Calculated pressure drop is higher than 1 bar gauge, so I can go to the scenarios part, choose this scenario and open the scenario and change this part to 1.1 bar gauge. Okay, I'll be back to the PSV1 line sizing for PSV1 and run for all scenarios again. Okay, it says that the back pressure exceeds the maximum allowable back pressure by PSV. So I should be back to the scenarios part and choose the blocked valve outlet with 10% of build-up back pressure. As you see, the variable can be changed to 0.5 and it can be changed to 0.8, and okay on this part, and the PSV1 okay, all things are okay and the simulation is complete. The green ribbon shows that the safety analysis environment is okay for 2 scenarios: blocked outlet and abnormal flow through the valve. Finished.